did some platform testing for firewalls. I used to be working in Cisco for a while. And then I moved to a technical marketing role where I pivoted to, roles where I can talk to the customer, talk to the sales, and help bridge the gap between product management and sales teams. Currently, I'm in product marketing, and yeah, so glad to present this topic today. We'll look at the agenda. We'll start with application level security, what application layer is, what layer 7 is. A little bit of information about Istio and service mesh, like Raj pointed out. What's the deal with service mesh and sidecars and all that with containers. And do you really need a service mesh to help with security and observability for containers? There is a demo in the end, but it's not going to be the full-fledged demo with everything that is spoken about, because it might take a very long time, and I'm probably not the right person to do it. I'm currently not hands-on with technical stuff, but I'll try to do my best with showing how Calico can be installed, what's the the nuts and bolts of the solution. So we'll start with application level security and get to the basics of what application layer is, OSI on the OSI model and so on. But before that, since we are dealing with containers and Kubernetes for today, I just want to give a very brief introduction to containers. I'm not sure how many people are familiar with it, but let's just look at on a very high level what containers are. I'm sure that most of you are familiar with VMs and virtual machines running on ESXi and so on. But what's the deal about containers? People talk about Dockers, containers, Kubernetes. So what do these things mean? So when you look at the simple architecture of a virtual machine, you see that it has the infrastructure, all the physical components of the hypervisor, the ESXi servers, and so on. It has a host operating system, and on top of that runs the hypervisor to enable virtualization. And you have different VMs. So if you look at the red pillars, App 1, App 2, and App 3, imagine App 1 with the binaries and the libraries and the guest OS. That forms the typical virtual machine. So you have 3 VMs shown here. It's a very high level logical diagram, but that's what VMs are. It shares the host operating system and the hypervisor piece, but it has a guest OS running on every machine. So it actually requires a lot of resources when you look at it. When you look at the virtual machine itself and how each VM has to run a guest OS on that, and quickly look at the right side of the diagram where you look at containers, and you notice there is a small difference that the containers don't have any guest operating system on it. So it makes it much more efficient in terms of resources. It doesn't take up that many resources. So, I mean, to put it in a very simple definition, imagine containers to be lightweight forms of virtual machines, where it just shares the OS kernel with other containers, but doesn't have any type of guest operating system on its own. Of course, it does come with all the binaries and libraries that's needed for running a container, and that's basically it. And it's also running as isolated processes in the user space on the host operating system. And there is also another, logo right in front of the container, logical diagram here. If you're familiar with that, then you'll probably be interested in the future slides that are going to come up. So that's basically Kubernetes, and so Docker started the whole process of orchestrating containers using Docker Swarm. And before that, it was up to the end user to use any type of inbuilt or in-house solution for orchestrating containers, because the way containers are built, it's a very complex system. There has to be hundreds and thousands of containers running for an application, and it was very hard to manage these containers. So Docker came up with a solution to, initially they came up with the solution to prepare containers for runtime and so on. But just with the orchestration part, it was kind of difficult. And then back in around 2014, sometime, Google already had their own version of Kubernetes running in their data center. It wasn't out in the open yet. They were just using it as a in-house project, and then looking at how useful it was, they launched it in the open and became an open source project, and they donated it to CNCF, which is the Cloud Native Compute Foundation. And people started using Kubernetes, and right now it's probably the most adopted container orchestration tool there is. So, I mean, even though Kubernetes is open source, what people did was, companies like Red Hat, AWS, and Azure, these folks took Kubernetes and put kind of some kind of a wrapper around it. Even if you've not heard of Rancher, they're another managed Kubernetes service. I'm sorry, self-managed Kubernetes service, which is more like private cloud. And what they did was made it easier for people to use Kubernetes. Kubernetes made it easy to maintain containers and secure and control the container behavior. But then all these services like Rancher and Red Hat OpenShift, they made it easy for people to use Kubernetes. All right, so let's look at application layer security and observability. So by default, Kubernetes doesn't offer any type of security for the application. I mean, there is definitely some kind of security that is part of the Kubernetes platform itself with respect to all the control plane components of Kubernetes. But when you are building an application, it doesn't know anything about the workloads or the containers running within your application. Sorry, I'm seeing some kind of a message. Okay.
It's a Q&A. You go ahead, Giri. No issue.
Yeah,
Go ahead.
Yeah. So for this talk, we'll just focus on how application layer security and observability matters for Kubernetes and containers. There's a lot of stuff to talk about, but why we focus on application layer is because any type of service that's running in microservices, it's actually handled on this layer, and there is no default method or component of Kubernetes that can handle this. So if people are not familiar, some of you might not be familiar with the OSI model. With this like basics of networking, going back to what the OSI model is. You could do if you're interested, you could do a Google search and read more about this. But the OSI model basically talks about the different 7 layers of networking. If you're curious what happens when you type in a domain address on your browser, you could actually go through each and every layer on this model and explain to someone how internet works, basically. So that's the concept of the OSI model. And what you see on the topmost layer is the application layer, and this is the layer where I'm sure everyone here knows about HTTP, and that's the protocol that's part of the layer 7. And that's what we are interested in. When we say application layer or application level, we're talking about layer 7 and HTTP in this case, because in microservices, that's the most common type of communication that happens within services. And I mean, there could also be a situation where these services use HTTPS, which is, secure HTTP, but most likely it's still HTTP. And these services, they actually, what they do is they invoke a, a web API request, and it's based on the HTTP protocol. And like I said, the problem is, when you look at the service level communication, it's all about monitoring and understanding what's going on between these different services within your application. Uh, uh, and I mean, folks, if you're interested in knowing more about microservices and containers and all these, it's not an abstract concept anymore. People are already using it in production. Most websites, most apps these days. I mean, think about a banking app, financial app, think about your insurance application. All these are probably running containers and probably managed by Kubernetes. I don't want to give a very specific example because you might not know these businesses, but just think about Visa, the credit card service. So that they're probably running Kubernetes, and they've been using microservices for a long time. So these technologies are matured enough, but the problem with security and observability are not up to that level of adoption, because people just want to get the application out running, but are still learning things about security in the market. So what? Oh, sorry. So what kind of observability challenges does Kubernetes pose? So one is data collection and correlation. The problem with microservices is you have a huge amount of data compared to a monolith application. If you look at a containerized application, just the amount of log data is just humongous. And the other problem with large amount of data is also correlation. So how do you understand which flow log belongs to which workload, which HTTP response code corresponds to which container, because these containers are running in the hundreds and thousands, and they also, restart. I'll get to that later, but the whole thing about Kubernetes is that it's designed in a way that if something goes wrong with your container, or let's say pod, so pod is actually, I'm bringing in too many terminologies, but stay with me. And if you have any questions, please post it on Q&A. I'll pause my recording and look at it. Sorry, pause my presentation and look at the questions. So pod is actually a Kubernetes component, which is the smallest unit of, I would say, smallest unit within a Kubernetes environment. And typically a pod will have one or two containers, or a couple of containers running within a pod. And I'll use pods or workloads interchangeably, so it all means the same. And correlation between all these data is just really difficult. And also aggregation of these data. I mean, you cannot just randomly present the user with a ton of alerts and then ask them to go figure it out. So that is a challenge. And also, when I said Kubernetes context, Kubernetes adds a layer of abstraction on top of the host or the VMs. So while collecting and aggregating data from individual containers, the data needs to be correlated and aggregated at different levels of abstractions. There's one more challenge. How do you map Kubernetes policies to traffic flow in real time? Because when you look at security, I mean, it has gone to a point where the operations security operations team are looking at a ton of alerts. Like probably a big enterprise like Visa is probably looking at almost 10,000 alerts per day or even per hour. So you need a mechanism to uh, map these policies, network policies to traffic flow. And by default, you don't get that with Kubernetes. So this is also a huge challenge. I mean, just when you look at the teams involved with handling Kubernetes and containers, the challenge really is actually looking at service to service visibility. So one is it's a distributed architecture, and it runs Kubernetes can run applications across multiple nodes, and it's very difficult to monitor and track them. You also need a granular level of visibility, and you cannot just say that packet is going from this node to that node without any context of what the timestamp or the the other details of the particular flow. You need much more granular level of context within the Kubernetes workloads itself. And of course, I said it's a dynamic environment. When I say dynamic, imagine a pod is involved in the application. It's sending out traffic, something goes wrong, and then the pod is restarting. You need to have the historical log data from a pod that is being restarted, and also the new pod. So all this combined with the other things that I've been talking about makes it really difficult for a user to understand what's going on. And also, I mean, when I said Kubernetes by default does not have any features, so just using the native form of Kubernetes, vanilla Kubernetes will not give you any built-in tools for monitoring or troubleshooting. You won't have packet capture. You will not have any dashboards. You're just presented with a blank screen with a couple of kubectl commands at your disposal, and it's up to the user to find their own method of troubleshooting all these problems. There are some built-in metrics and logs, but I mean, for a real-world scenario, I don't think those are useful. Let me pause here. If you have any questions so far, please feel free. I'm not an expert in this field, so if I'm not able to answer any of the questions, I'll definitely take it to my team and come back with answers if it's really something that you're interested in. But feel free to ask questions. So you looked at the challenges. You will look at the solution, but then what prompted these people to come up with solutions? What do you actually need for solving these problems with security and observability? So one, you would need flow logs. Basic, you have to have information of layer 7 traffic, which is it could be any type of layer 7 flow data. It can be start time and end time of the packet flow. It could be number of bytes in and bytes out. And within, when we talk about Kubernetes and containers, it's also important to know the source and destination namespace of a particular flow. And I've just introduced another term for you, which is namespace. So namespace is a Kubernetes specific term that they use, and think of namespace as a logical group of resources that perform some kind of work within an application. So just imagine an online retail store, like Amazon or something, and they have a checkout service, they have a product catalog service. So imagine the product catalog and checkout as namespaces. Also, what the typical suggestion with Kubernetes is if you're starting out with just couple of users, don't use don't use more than one namespace. Start with the default, and based on the complexity and scale of your application, you can start creating users. I mean, namespaces typically are used when you have multiple users managing the application, developing the application. So that's the fundamental reason for the concept of namespaces. So the second thing that you need for security and observability is policies. So without policies, you cannot, some kind of security policy, you cannot block or allow or deny or drop packets at layer 7. So you need some kind of policies, and Kubernetes policies, the network policies that Kubernetes has is super basic, and you cannot do much with that. It doesn't offer fine-grained access at all. And when you look at security itself, you have to have protection against the application layer threats. I'm sure I introduced the concept of HTTP and all that, but if you've heard of things like SQL injection or cross-site scripting and cookie poisoning, all these happen at the application layer, and someone who has even just no other tools in their at their disposal, but just has access to your internet-facing application with just your web page, they can probably create things and kind of infiltrate your application with all these things that I spoke about, the SQL injection and cross-site scripting and so on. Just with a couple of form fills or some kind of a page where you have, let's say, a username password field. If your application developer has not been careful enough to develop, look at all the security and threat modeling while creating the application, you're for sure you're going to get breached. So you need something at the application. So these happen at layer 7, and you need some kind of protection against these attacks. And OWASP top 10 is actually, so OWASP is a nonprofit community which actually has a list of top 10 threats when looking at application layer. And I would encourage you to go to that website and understand what these attack means. So they keep refreshing their top 10 every year. I think I have a couple of questions. Let me look at the. I don't want to bore everyone with just talking nonstop, so I think I'll just take a break and look at the questions. So one person is asking, to what extent is AI implemented to provide solution for proactive issues? I'm sure this is coming from all the news about ChatGPT and all the machine learning and AI that's happening. So a lot of security solutions are actually doing machine learning. I don't know if AI can be it can be relevant here. It's probably a long way to go in that aspect. So there are a lot of solutions which use machine learning. It's not it's not something that hasn't started yet. But AI, I'm not sure about that. I don't think we are at a stage where there is any concept of AI with security and observability, or even anything to do with containers, any type of enterprise applications. One more question or comment is, application to application communication is mostly API HTTP driven. Can't these be monitored? I mean, when you just talk about I mentioned this thing about monolith. So monolith is, again, I'm just assuming that some folks in the meeting are not familiar with it. So monolith is the traditional way of building applications. It's the exact opposite of containerization. And in a monolith application, I think doing monitoring for HTTP communication is probably easy, or I can say it has been figured out. You have solutions to do that, but my point was specifically about containers and Kubernetes. It's not, the problem is not because you can't build a solution or people don't know how HTTP works within containers and Kubernetes. It's just getting all the information, putting it in a system where it's going to give you a clean output and context-based output of what you exactly have to look at, and that's the reason why it's not easy. If my application is protected behind WAF, do I need to take any additional measures? So that's an excellent question. I'm glad you asked about WAF. I was just talking about application layer threats and OAuth top 10. So web application firewall, WAF is web application firewall, and you can actually protect your application with a WAF. But again, the whole landscape of containers and Kubernetes is so different, and people are still understanding the service-to-service communication that I'll just provide some answers with respect to WAF. So typically, when you deploy a WAF or a web application firewall, you put it at the perimeter. So imagine you're developing a cloud-native application and you're putting this WAF at the perimeter. And when I say perimeter, I have to give you some context about what perimeter is with respect to Kubernetes. So I'm just going to quickly, maybe I think I can show you a visual representation of what a Kubernetes cluster means. So if you go to the Kubernetes web page, it has something called Kubernetes components. This is a very good starting point to understand what Kubernetes is all about. So you see this, this whole gray box, that's a Kubernetes cluster. So the things that I spoke about, pods and nodes, all these reside within the cluster. And to set context for a cluster, let's say, you're building a new application. Let's say you're building the next Instagram. I would say for a company like that, you would probably need just one cluster to start with, and based on scale, you might want to add one more cluster. So cluster is actually a very high level concept in Kubernetes. So everything within a cluster is all part of the microservice architecture. So where was I? I was talking about web application firewall and perimeter. So when you think of a WAF, a traditional WAF, like let's say Imperva or any other WAF, you're putting it at the perimeter where it has information about traffic leaving the cluster and entering the cluster. But what happens within the cluster, that is, communication between microservices, it is oblivious to it. It has no idea what is going on. And if you're familiar with how threats propagate within an application, if you've heard of lateral movement, your WAF is not going to catch that. So let's say a malicious actor has entered your application and they're doing some kind of activity where there is a part of it where it's at the application layer and they're sending a packet with the HTTP header that is not meant to, which is not meant to be part of the application. So that is when a web application firewall that is built just for containers and Kubernetes will help. And that is why you cannot use a regular WAF. Of course, it's a good question. You can use a WAF for, it's better to use a WAF on the perimeter, but you need some kind of solution that can understand, traffic which sits within the cluster and understands or inspects service-to-service communication. How do you manage customer data protection while implementing flow logs in a multi-tenant cloud service? So, another good question. There is, I'll probably cover that in the next few slides. So with Calico's implementation, so Calico is, the solution that I'm going to talk about today. That's the solution that we offer from Tigera. It's a open source solution which started as a networking and security solution, and we built multiple things on top of that. But with Calico, when you when you're talking about application layer things, one way what we've done is we've used a efficient model of implementing Envoy as a daemon set. I know I'm getting ahead of my topic, but you can actually encrypt flow, traffic at layer 7 using Envoy. So that's what I was going to talk about. So there is an open source project called WireGuard, and we've integrated with WireGuard in Calico, and you can actually it's actually much easier than other types of encryption where you don't need to deal with certificates and keychains and all that. It's just a simple way of enabling and disabling encryption at layer 7. So I don't know if I've answered your question correctly, but if you're talking about data encryption, that's one way to do it. What policies are required at application layer? So that's what we're going to cover. I know you're super excited to look at policies, but we'll cover that in the next couple of slides. I'll get to it. All right. Yeah, that's about it. Thanks for the questions. It was actually, it's very useful for me to understand the different types of questions that you guys came up with. So appreciate it, and please feel free to post more. So we spoke about application layer threats and OS top 10. So the other, type of threat that is common with any type of application is DDoS, which is distributed denial of service. So put it in, again, if you're not familiar with the DDoS attack, I don't know how many of you grew up in the 2000s when email was hot and people spoke about email bombs, where you could send someone, if you hated someone, you could just send them an email bomb, which has about 10,000 or 20,000 emails, and there the server will crash and they'll probably not get an email. So I know it's a bad example, but something that's very similar to DDoS attack. Someone who does not like your company organization is trying to bring it down. They can send a ton of HTTP requests to your application and bring the app down. So that's basically a very high level explanation for what a DDoS is. And this also happens at layer 7. When you say HTTP request, obviously it happens at layer 7, and you need some kind of protection to at least detect if a DDoS attack is going to happen. And interestingly, I'm just not sticking to the slide itself, but I was reading an article about how Google's security team actually prevented a DDoS attack last year, which was, it set a record for the amount of requests that came in. So they actually had a Google Cloud customer who looked at, some weird communication within the network, and Google immediately alerted them, and they actually saw the spike of requests that went above 40 million requests. So it's a very interesting topic in itself, and how it's interesting how these security solutions, like some providers actually combine WAF with DDoS, and it's pretty common to see both offered by the same company. So yeah, with Calico, what happens is you can actually look at a particular layer 7 field. I guess it's called the HTTP request spike that we collect data about, and anytime this graph goes high, the request spike is above a particular level, you can actually get alerted and assume there is going to be a DDoS attack, and take preventive measures. So that's another security challenge, or things that you need. And finally, just visibility into service-to-service communication. When I say visibility, it could mean a couple of things for different people. But one great aspect is actually looking at how your nodes and clusters and namespaces are. I mean, all these are. I showed you the diagram in the Kubernetes website, but then when you actually start building applications with containers, there is no UI, there is no visualization of how these things look. I mean, you probably don't have an idea about the mapping between different services. So that is a problem when it comes to visibility. And also, looking at actual visibility itself in terms of traffic communication, we saw all the challenges that are present in Kubernetes. So yeah, so that's about all the things that are needed. And another byproduct of having a good visibility solution or observability solution is looking at performance. We spoke about security and observability, but again, you can use this for observability. You can use this for performance issues, where you can look at latency, DNS latency, and any type of HTTP errors, or a lot of data that you can look at to see how your application is performing. This is, I think, very useful for DevOps and SRE teams, where they're required to see or make sure that the application performs well. I think I might have another question. When you said within Kubernetes, it's difficult to monitor threats. Can SIMs or help in identifying or aggregating those data? So a SIM or a SOAR will, SOAR cannot identify any, I mean, sometimes I think it can, but SIM definitely, even though they might not require, context about the container itself. What solutions, typically what these solutions do is, like even Calico, we actually export data from our solution over to a SIM. So I think a SIM can have its own style of identifying data, or looking at threats or any type of issues. So it's a good question again, and it is an additional level of threat identification that you can use. So you can use SIM and SOAR, but it is not sufficient to just plug in a SIM solution within your Kubernetes environment. It will not be able to. So since it doesn't sit in the same level as the infrastructure, it doesn't sit in the infrastructure level. That is, it doesn't understand Kubernetes concepts. So it's difficult to correlate data, which a solution like Calico can do, and then export logs to SIM. So we basically partner with a lot of SIM and SOAR companies to help with getting data. Can you please share any links which describe more about how GCP prevented DDoS? Let me find out maybe towards the end of the presentation. But if you just Google for DDoS attack Google Cloud, you will probably get that result. But yeah, I'll try to get that towards the end of the session. We talked about operational aspects. Okay, sorry, I need to repeat the question out loud because others cannot hear it. So the first question was about when you said within Kubernetes, it's difficult to monitor threats. Can SIEM or SOAR help in identifying or aggregating those data? So that was answered. And then link about the GCP example that I gave about DDoS attack. That is the second one. The third one is you have talked about the operational aspects of managing Kubernetes security. Can you touch upon how security postures in Kubernetes clusters can be audited, particularly in light of its ephemeral nature? That's a very good question. So if you're talking about compliance, I'm assuming that's what the question is about. Uh, Compliance is actually very hard with these solutions because if you ever work with auditing and policies, auditing and compliance, what they would, some of them will require is historical data. And if you go tell them that, hey, my pod restarted, so I cannot give you that information, you're going to either going to cancel your compliance, or you will not be allowed to run your business. So we actually so Calico by default doesn't offer that, but if you look at our enterprise solution, they do offer some kind of compliance solution. So it is actually very difficult to do it if you don't have the right tools. And you're absolutely right. I mean, to get the contextual data about which pod has restarted, what data it was carrying, and all that. Uh, uh, you can actually, so there are a couple of things. One is compliance like GDPR, HIPAA, and PCI. So what you would need is a regular reporting facility that will give you, detailed reports either by the hour or the day, week, month, so on. And you need to have some kind of customization within the reports itself. You cannot, just rely on basic reports, and you need to probably middle around with some of the customization, like the time range, or even the type of data that you want. And the other type of security posture audit is about, I spoke about the Kubernetes control plane. And if this control plane is not hardened, security hardened, you'll obviously have threat actors attacking your infrastructure or your platform. And so there is a concept called KSPM, which is Kubernetes Security Posture Management, very similar to a CSPM, which is Cloud Security Posture Management. So KSPM has, you can again get reports telling you how secure your Kubernetes infrastructure is. And one example would be something called a sys benchmarks. I'm not sure if this person is familiar, but sys benchmarks is it actually a set of standards where it will tell you, your, let's say in your Kubernetes platform, there's something called HCD or API server, how these different components are configured. If someone setting up Kubernetes for the first time is not familiar about these things, and if is given privilege access, you're given sudo root access to to everyone in the organization, things can just go haywire, and you need some kind of a method to make sure that these things are secure. And yeah, I hope I've answered that. Thanks for those questions. And let me continue. So moving on, we were talking about the challenges. So solution is, I mean, how do you solve for these challenges or problems? We know that most of the service to service traffic is at the application level. And what Calico does is, I'm here to talk about Calico, which is the open source solution that came out maybe around 2016, just when Kubernetes adoption was increasing. This came out of, Calico is basically, it started as a software-defined networking solution for open, trying to remember, I think it was open, not OpenShift, it was another SDN solution that was in the market. And these folks at Metaswitch were trying to come up with a more elegant solution for that. And that's how Calico started. And what happened from there is they also designed a CNI, which is container networking interface. So CNI is basically, a way to provide networking for containers. So you know that Kubernetes is orchestrating these containers. It has information on what the state of the application is, but how do you how do you make sure that these different pods and workloads communicate with each other? You need some kind of a networking tool. Imagine a switch or a router. You cannot obviously put some kind of a hardware switch in between or a router between. So SDN is the answer, and you need the SDN for containers is usually called CNI, which is the networking interface. And one of the there are two primary use cases for a CNI. One is providing the networking, providing layer 3 networking for containers, and the other one is also handling the IP addresses, which is in the form of IPAM, IP address management system. So Calico is started as a CNI and started building out things like policies, where it became the default policies for a lot of Kubernetes deployments. So Kubernetes by itself has policies by default, which is actually based on Calico. So when you install Kubernetes, and if you look at Kubernetes network policies, that is nothing but Calico that is running. So that is the open source version. And what we do for application level observability is, I mentioned sidecar and service mesh and things like that. So let's get into that piece now. So we provide microservices observability using Envoy. So Envoy is it's like a proxy that sits between your workload and the other services. So imagine that it's called a sidecar because it sits right next to the workload, and any type of service level communication that needs to happen with other workloads, it goes through the sidecar proxy. And that's basically it brings in another control plane to the equation, and it just gets more complex, but that's the only way to do it. So let's see what is happening here. So Envoy can be integrated with Calico to provide service to level communication. But when I say integrated, it's actually we've used Envoy to be installed in a very easy manner. And if you're when I say it gets complicated, I'm talking about using Envoy without Calico in the picture at all. So if you don't have Calico, and if you want to look at service to service communication, the only way is to install Envoy or Istio on your own and some kind of a service mesh and look at all these things. But the complexity and the problem comes when managing Istio or Envoy itself. So we have taken that challenge or problem out of the equation and made it very simple. If you're using Calico, it's just a couple of commands and you're good to go. You'll get all these benefits that are that we're going to see. So what it does is, so when you install Envoy as a sidecar, what it provides is it'll provide flow logs for application level traffic. So all the HTTP metrics and things that you're interested in. I don't know if this screenshot is large enough for people to see. Let me try.
Yeah, we can see, Giri.
You can see. Okay. Okay.
Yeah.
So it has a HTTP request duration, requests over time, all the different types of metrics, and also the best part about this is it'll give you information with context, that is where which namespace this is coming from. So if you look at the,
if you want, you can focus, Giri. If you want, you can.
Oh no, that's okay. Yeah. So if you look at L7 all services, it talks about front end, cart service, currency service. So you can actually drill down and see which particular service is performing, how it's performing, and so on. Yeah, and the other thing is it also provides valuable metadata about these flows. So metadata is the data that is enriched on top of the regular L7 data that you see. So that will be things like which pod is it coming from, the when which node the pod is part of, and so on. And I think I mentioned this before. It also allows people to, when you use Calico, it allows people to use WireGuard as an encryption technique, where for data in transit encryption, you can just enable WireGuard without the need to do anything. So it's automatically encrypted. All L7 traffic is encrypted when you enable WireGuard. So that's another benefit, and that's how Calico is, providing a solution for all the challenges that we looked at. Uh, so I think this slide is just talking about all the different types of flow log data that you see. Um, source and destination namespace. I think I mentioned this. The URLs, the response code. So many fields that can be useful while troubleshooting. Yeah, so when I spoke about service mesh, it actually really brings in a lot of complexity, because I mentioned it adds another new control plane to your equation. So you need to know how service mesh works. You need to understand how to maintain, install it, upgrade it, and so on. And that is almost like having another solution on top of Kubernetes. So with Calico, what you get is the same benefits of a service mesh, and an easier way to use some of the benefits. So, the most popular use cases for the service mesh will be observability and security. Things like encryption I spoke about. You don't need to use a service mesh for encryption because you already have WireGuard enabled. Um, you need to look at service communication. You get that with Envoy is a sidecar model. You've already installed that with Calico, so you don't need to install a service mesh like Istio separately. So we've integrated everything within Calico itself. Again, so I think someone asked about security posturing. It's that's also another benefit. You meet organization or regulatory compliance. So some of the compliance requirements will be specifically around application level, application protection. So someone asked about WAF, and I shared some information on WAF. There are some compliance standards which actually require you to specifically, there is a line item where you have to say, I have a web application firewall installed to be, to uh, uh, pass your compliance exam. So that's another use case. Let me take a pause and look at some Q&A. So the first question is how to analyze flow logs. Will it not be humongous? It will be humongous. Yes, it is true. But again, I think I'm not sure what role you play. But for folks who are familiar in the security uh, uh, business, and if you've used solutions like an NDR or an EDR, network detection and response solutions, or even SIMs, it is a lot of data. But then the the task for these solution providers, like let's say Splunk, who's a SIM solution provider, or SOAR solution, or even Calico, for example, the task is to make it easier for the user to analyze things quickly. It's not, if you use Calico or I'm just talking about all the other solutions available for different reasons. Instead of taking hours and not hours, maybe days or weeks, the idea is to bring it down to a couple of minutes or even hours. So you do have various features to analyze flow logs in a much more easier way, and that's the whole concept of coming up with solutions which can do that. And when I say it's the task of these solution providers, what we do is with Calico, you can actually look at flow logs. You can actually drill down with something called service graph. We have something called dynamic service and thread graph, and what it will show is visually it'll show you the namespaces. Start with the cluster, it'll show the namespaces and different workloads, and you can actually drill down to each level up to a pod level and actually see the flow log. So it doesn't have to be flow logs at the cluster level where it'll be like maybe millions of entries. So that's the whole concept of Calico, or any. I'm sure there are other providers which do the same thing. So yeah. The second question is, can a WAF parenthesis CDN providers plus internal WAF plus some sort process and security log analysis and open vulnerability analysis using Splunk and Uptex maybe address this issue? Yeah, it can definitely address the issue for application level security. So that's what I've covered so far. And when you say internal WAF, I'm hoping you mean the WAF that I was talking about, where there is something that is installed within the cluster. So, one of our products actually has a solution called workload centric WAF. You can actually, it's part of our offering. And I think I've looked at a lot of solutions like Palo Alto and other big players, and it's actually very hard to find something that is at the workload level. And we've actually leveraged an open source WAF solution. Let me recollect what the name of that solution is. I'll think about it. If it crosses my mind, I'll let you know. But you're right. I mean, to address this issue, you can use all the combinations and multiple solutions that you've spoken about. But the idea is who can provide that? Who can provide that internal WAF that we've spoken about? And this is just one aspect of security within containers and Kubernetes. It's not just application layer, or it's not, an attacker can come into your container where there is no concept of any network. He's just, there is some vulnerability in your container image, and the attacker, he or she, is getting into the container runtime, doing something within the kernel. All this is not going to, be detected through a WAF or a SIM or a SOAR. So I understand the question, but then there is just so many things to container security that just one solution is not going to protect you. And the idea is, people are trying to build a single single solution which can actually do multiple things, just like a UTM. There's another question: how does the onboarding process work to integrate Calico? If you're asking about onboarding process to install Calico or integrate Istio with Calico, so all this will be available with the documentation. I'll, towards the end of the session, I'll share the link to the docs. In fact, let me actually just do that right now. Okay, and let me put it on chat. And if one of you can tell me if you got that link, that'll be good.
Hey, move ahead. Agree.
Sorry?
Idea.
I'm hearing.
Yeah, I think it is there. It's there in the chat. Go ahead.
Okay. I'm also hearing some kind of a beeping noise.
Now it's okay. Yeah.
Oh, yeah. Oops. Do you hear that too, or is it just on my end?
Yeah, sometimes
Continuous
popping
beeping.
up, sometimes coming. Yeah.
Oh. So let me disconnect audio and join once. Just give me a one. Sorry about that. I think my keyboard was on top of the laptop.
Okay, it's okay now. Yeah.
Okay, yeah. So I'm documentation link. So the onboarding process, if you're talking about how to install Calico or how to install Istio or Envoy with Calico, everything is in that page. You could definitely go to that and look at how things are done. There's another question, can Calico data be taken into tools like Prometheus or Grafana? Not with the open source, but yeah, we do have a way to, we have our own Kibana dashboards, but there is, a facility to export it to Prometheus and Grafana. And I think the documentation should probably cover that. Do cloud providers, the last question, or actually one more question is, do cloud providers like AWS or Azure support Calico from their own Kubernetes management capabilities? Okay. Yeah, they do. And they do it in a very different way. AWS, EKS, or Elastic Kubernetes Service, for people who are not familiar. So that's a Kubernetes managed service that is provided by AWS. So they do offer Calico as a choice of CNI or even policy. So when I say they do it differently, EKS does it in a different way. You can actually use just Calico for CNI or use Calico without a CNI and use it for security policies. With Azure, you can actually, there's a new concept called bring your own CNI, where previously Azure had no option of any other CNI except their own, which was called Azure VPC CNI and KubeNet. And I mean, the interesting thing is Azure VPC CNI itself was actually Calico underneath, but I don't know why we never promoted that, but right now they have a concept of bring your own CNI where you can actually bring Calico as a CNI. And on top of that, either without the CNI or the CNI, you can have Calico integrated with AKS on Azure for security policies. So yeah, we do support all major public cloud providers. We're also available on Red Hat OpenShift, Rancher, what else? Google Cloud, yeah, everything. One more question. When you use the term workloads, it refers to what elemental level of granularity? A few examples will help. Great question. It's actually, yeah, I think I mentioned I interchangeably use workload or pods. When you say workloads, it's actually any unit of compute which is programmed to do a particular work. So in this case, typically when you talk about Kubernetes and containers, a workload is actually a pod. So, and when I say pod, it's actually, pod is running one or two containers within that. So you could even remove that abstraction and say a container can be a workload. So it's kind of a generic term, but when I say workloads in this case, so imagine your application is doing multiple things. You have different services for different parts of your application. And when a particular, let's say in your retail application, you have checkout service. Checkout service will have, I think, again, smaller chunks of software, and each piece of software can be thought of as a workload. And that will ultimately be a pod. All right, so let me go back to the slide. So moving on, I think we've looked at all the challenges and solutions, how Calico solves for this problem. I did mention, Istio, sidecars, service mesh, and so on. Let me provide a little more, add a little more color on what these things mean. So um, when you typically have an application, you build an application, you would need, I'm talking, and here I'm talking about containerized application. You would need a way to interact with the application, right? To understand the security, understand performance and observability, and so on. And you don't want to disrupt by sending in multiple requests when it is in production. So you need to use some kind of a debugger, or you need to snoop traffic, you snoop packets, you need to sniff out packets to look at traffic. And in for this scenario, what people did was come up with a sidecar model. I think I mentioned this, but yeah, sidecar model is basically, it puts a proxy in front of your worker node. Again, I'm bringing another term here. Worker node is a Kubernetes specific term where it's nothing but nodes that participate in the application. So that's all a worker node is. So you have a kind of you have a proxy in front of these nodes, so that any communication that uh, goes outside goes through this proxy, and uh, all these features and functionality around observability and security that you need is taken out of this proxy and used. So it kind of becomes a gateway for application. And Calico, like I said, we integrate seamlessly with Istio to enforce layer 7 network policy within the Istio service mesh. So I think someone asked about policy implementation. So, and that's where it goes. So we provide, Calico is known for its network policy implementation at a much more granular level than basic Kubernetes policies. And what you can do is add, so these policies usually work at layer 3 or 4. And with the Istio integration, you can actually add application layer attributes like HTTP methods, put or get, those things, or even you can include actual URL paths in your policies. And that's basically how you do it. And what it means by pod injection is these two annotations that are shown here, Istio injection equal enable and sidecar istio.io/inject equal to true. We use these two annotations, and you can let the Istio pod injector know which workloads require Envoy proxy. You basically use this during implementation of the uh, application layer, integrating Istio with Calico. So to do this, we need to install Istio and configure Envoy. But once you do that, it's simple, couple of commands after this. So any pod with these labels, when you have any pods with the following labels, it will be added to the service mesh. All right. And we also spoke about Istio. If you're not familiar with Istio, it's basically the most common service mesh that is out there. And when I say service mesh, it's anything that is used to describe the network of microservices that make up applications and any type of interaction that goes on within them. So that is basically a service mesh. A service mesh, like the open source plugin, Istio is also open source, and it's think about service mesh as a way to control how different parts of an application share data with one another. Trying to come up with an example, but anyway, so it's a dedicated infrastructure layer built right into the application, and like I said, it's usually implemented as a sidecar proxy, and traffic flows through this sidecar proxy, and you can, have all types of controls with traffic management and security. And since it controls, any ingress and egress traffic to the services, you can extract information using this service mesh. If there's a HTTP call, you can figure it out and you can send it for monitoring. You can find out who's using SSL, who's sharing SSL certs to scenes, or use SSL certificate to see inside the traffic. Picture time. Okay, so this is another representation of what a service mesh architecture typically looks like. So I mentioned it introduces a new control plane, and when you look at this diagram, what you can see is the service mesh will let proxies to discover applications. So you see service B and service D, and there is a proxy sitting right in front of it. And this is where you apply the application layer policies to control ingress or egress traffic. So for instance, if, let's say there is a website, you have mysite.com, and you have a URL specifically within that saying mysite.com/do not enter. You don't want anyone to enter. There's no way for you to deny access to this URL unless you change some, server config or disabling the network. But with service mesh, what you can do is tap into layer 7 and write a policy for that particular URL so that you either block ingress or egress traffic to this URL. It can understand layer 7, it can understand the whole packet, and it can help to disable that particular URL. You don't have to modify your code, you don't have to go into the application, you don't have to change anything on your network for this to happen. Yeah, and as I mentioned, we have a seamless integration with any service mesh. And especially for Istio, it lets you enforce application layer attributes like HTTP methods and path. Excuse me. And some of the benefits for of doing this, integration with Istio is you can control traffic at the pod level. It'll restrict ingress traffic inside and outside pods, and mitigate common threats to Istio-enabled apps. You can adopt a zero trust network model for security, including traffic encryption, which is probably another requirement for compliance. It'll give you multiple enforcement points and also multiple identity criteria for authentication. And the last benefit is, it's a familiar policy language. Once you install Calico and you're using Calico for network policies, you don't have to learn a new type of policy language to control application layer, traffic. Or you don't even need to know how Istio works. So with Calico integration, there are two levels. So one is, let me actually pause again and see if there are any questions. I don't have any. All right. So when you look at Calico integration, there are two types. One is Calico network policy, and the second is Calico global network policy. And the difference is, I remember I mentioned about namespaces. So Calico network policy is actually namespace level, so you can enforce restrictions or exceptions within a namespace. And what global network policy does is for the entire cluster, you can enforce a policy or rule for the entire cluster as a whole. So you can add, so when you're writing your Calico policies, you can add these HTTP sections where you can either mention if it's a get or a put, and also an option is to provide an actual path for adding these restrictions. Next slide is actually, I don't know if I want to get into details, but this, the high level architecture diagram of how Calico is designed to understand, I mean, Calico, not just Calico as a whole, but Calico with Envoy as a sidecar model. This is how it's designed. So you see something called Felix. So Felix is the brain of Calico, and it's the control plane portion that lets underlying infrastructure know that this a particular traffic is allowed or not allowed. So let's say when you create a Calico policy, what happens is it goes to Felix, and depending on how many nodes, Felix will is inside the Calico node daemon set. So depending on the data plane, if it's eBPF or standard Linux, it'll create either IP tables or eBPF programs to limit or permit whatever you're trying to write. There is no mention of eBPF here on this slide, but if you're interested, if you want to know more about eBPF, I would encourage you to again, just maybe start to Google and read about it. So it's a very interesting way to get to the kernel level of any system, any application, and without disturbing the application itself, you can actually get a lot of things done. You can actually create a sandbox environment. You can write your own programs to get kernel level details, and it's the adoption and usage has just exploded. People are going crazy about eBPF adoption in the container space. So I would suggest doing a little more, reading on your own about eBPF. So yeah, so it's actually a data plane concept. So you either have eBPF or standard Linux, and what Felix will do is tell Dicaster is to inform the proxy. So you see Envoy that is sitting right next to the workload to it'll inform the proxy on the decision to make, either let the traffic go through or drop the traffic or block the traffic. So yeah, that's about the architecture of how a Calico policy works with Envoy for application layer. So this is how internally the policy flow happens. I think I don't have anything else to share with respect to the topic, but I'll just briefly talk about what Project Calico is. So I mentioned already it's an open source project, and we've had a huge adoption rate with a lot of companies using it. It's a very active community, so you could if you're on Slack, you could join the channel. If you're on Twitter or LinkedIn, you can follow Project Calico. And this community talks about cloud networking and security. And if you're having any issues or problems with using Calico, you can ask people on the community. So we have about 8,000 Slack members, the channel members, and about I think roughly. So this one says 320. It's not updated. I think right now, currently, we have about 500 active contributors to the project. So I'm sure you all know how open source projects work, and just the fact that Calico is actually currently running on 2 million nodes is testament to the fact that it's one of the most widely used security and networking solutions for containers. Um, so it's it's a community behind a pure layer 3 approach to virtual networking and security. It's used in highly scalable data centers. Um, you can also use Calico for VMs and native host-based workloads. It's not just for containers. Like I said, it's an SDN, and it also supports multiple architectures and platforms. I already mentioned the different public cloud vendors and private cloud vendors that can support Calico. And it's also, the best part about this is it's designed to be modular. So we have something called a pluggable data plane. And I just mentioned or spoke about eBPF and Linux. So we support any type of data plane. It doesn't matter if you're running eBPF workloads or Linux or even Windows. There's something called HNS or host network service for Windows environments. So Calico will work on any type of data plane. And in the future, if there is a new data plane that's coming out, which is faster, better, stronger, with our architecture, we can easily integrate to that. Um, I don't know if you're able to look at. Yeah. Okay. Um, I think I mentioned about the eBPF data planes and post network service data planes. And just looking at this slide, Calico opens with some of the benefits. Choice of data plane. You get it's a pluggable data plane model, and also for performance, there's been a lot of studies and articles written by some community members who've tested Calico with other solutions and found out that for different benchmark studies, Calico has come out with flying colors with respect to CPU usage and cost. And of course, I mentioned about the different types of workloads, and it's also exceptionally scalable. Did I mention we do layer 3 networking? So basically, the protocol behind it is BGP, and BGP powers the entire internet. So if BGP can handle internet, Calico can handle the internet too. So so when it comes to Kubernetes itself, it's Kubernetes native security policy model. So it's declarative in nature. You don't need to understand Calico as a totally different solution. If you're familiar with how Kubernetes, declaration, all these, the different YAML and deployments work, it's a unified model. You can easily understand Calico.
So, Giri,
Yeah,
Giri, you want to run Q&A?
sure. Yeah. Is there any security implement at service level for proxy? So how security issues taking place? So yes, they do. I think the service mesh itself. I'm sorry if you are hearing background noise. Kid is starting to cry now. So sorry about that. Um, so the whole concept of service mesh itself is to actually implement security controls, and the problem also with that is how you configure and use a service mesh. So there is implementation at the service level itself. Uh, but to understand how that works, I think you need to understand how service mesh works. You need to install Istio apart from Calico on your own and do it. So yeah. So the next question is, how is this product different from a CNAP? So CNAP is, if people are not familiar with that term, it's a Gartner term, which stands for Cloud Native Application Protection Platform. So I mean, it's just another way of talking about one solution which can do multiple things. So when you say CNAP, and when you say cloud native, there are so most cloud native applications are built with containers, and with container security, as I mentioned before, you don't you cannot say that, taking care of security with just installing Calico open source or just installing, a scene. So it's a whole range of problems that you can look at from a security standpoint, all the way from build time to runtime. There are so many, threats that can occur during build time and runtime. So let's say you're, tasked with deploying a container. Deploying an application with containers. So you take this, base image, put different layers on top, add extensions and libraries, and use a container runtime to make it a container. So a CNAP's task is to make sure that all these uh, stages like build, deploy, and runtime, you have some kind of a solution, security solution that takes care of the entire CI/CD lifecycle. So Calico open source itself cannot be a CNAP because it doesn't offer all the capabilities, but our commercial offerings do much more than what Calico open source can do. So that is a CNAP. So with Calico open source, what you get is security policies, and the CNAP is much more than just security policies. Can Calico log any changes to containers nodes if I make any changes in its production environment? How that is tracked? Calico log. I'm not sure if I understand this question, but so I think if you're talking about changes that you're making within Calico itself, if you can track these, yes, you can. But let me read the question again. Can Calico log any changes to containers nodes if I make any changes in its production environment? Okay, if you're changing any parameters within containers, can Calico track this? I don't think it can track everything and anything. Anything to do with, if you're talking about the data plane, if you're talking about traffic, with network and security policies, yes, it can track, but depending on what you're asking, if it's something to do with the application itself, I don't think it can track everything. I don't think any solution can track everything what's happening within the production environment, but I'm sorry, I'm not 100% sure on what that question means. If I answered it correctly.
But the answer is yes. Yeah, its changes can be tracked, not all, but yeah, some part, including the networking. Yeah.
Oh yeah.
Okay.
Yeah, again, brand slide to show how popular we are. Calico is running on 2 million nodes, and we have about 1 billion Docker tools, and it's running on about 50,000 enterprises globally.
So, can you run that the poll and Q&A question? I can run. I can. Yes, launch now.
Okay. Okay.
So, yeah, you can see.
I can see it.
Yeah, probably you can explain this. Yeah.
So should I wait for people to answer? Yeah, I think.
Yeah. You can wait.
People are answering.
Yeah.
Okay.
1 minute.
Oh, the participants won't be able to see the answers, right? Response.
They will able to. Yeah.
Oh, they will. Okay.
Yeah,
okay. Okay. Yeah. Let me end the poll. Interesting. So the question is,
it's coming. Probably a few more seconds. Yeah.
Okay. So I think there might be a typo or an additional word in the question. So it says untitled containers, but it's just containers. It should start with containers share the OS kernel with other containers.
Okay, we ended Paul. Probably you can explain.
Oh, okay. Yeah. So the answer is true. So just going back, let me quickly go to the slide. The very first slide, I think, that I'm showing. Um, yeah. So if you see here, I don't think it shows any kernel level. Okay. So yeah, the concept with containers, it shares the operating system kernel with other containers, and that is both a boon and bane. So the disadvantage is if someone has access to the kernel level, then they can go to any other container. So that's called a container escape, and that's a huge security gap in how containers are built. Uh, so yeah, it does share the OS kernel. And in a typical VM, you have no access to the OS kernel. Yeah. So the answer is true. How do I
Okay,
bring the next question?
Yeah, I'll start for you. Yeah.
I'm still seeing just
You
the
can go to the
first question.
polls. You can go to the polls and
Oh, question two.
polls. Go to the polls and launch again.
Okay. Launch.
Yeah, I launched for you. Yeah, correct.
Okay.
Yeah.
I have a couple of more questions. So someone wants to know if there is a timer for the question.
1 minute. Yeah, 1 minute.
Okay. Okay. So 30 seconds more, I think.
Meanwhile, I have copied the feedback URL as well in the Menti. Please give your feedback as well. And this is to improve our session. Please check the chat window, click on the Menti link which I have given and give your feedbacks. It only take a one minute, less than 1 minute.
Yeah, I think we've crossed the 1 minute
correct,
mark.
yeah.
So yeah, the question is, why is application layer monitoring a challenge in Kubernetes? So it has multiple choices. One is distributed architecture. It's a dynamic environment with pods restarting every few seconds or few minutes. There's no native Kubernetes support for monitoring, and it's a complex architecture. So the answer is everything that is mentioned. So all of these are challenges for monitoring. All right. So I'll have one more question. Oh yeah, let me launch this. Should be simple, fairly easy and quick. Oh, wanted this to be like a question without any choices, just that
so probably
people
you
can
can
answer, but it's okay.
Yeah.
Yeah. So the question is, what is the proxy that Istio uses to implement service mesh? So yeah, Istio is it's an open source project, and they use the sidecar proxy called Envoy. So I think Envoy was built by Uber or Lyft, one of these companies. So yeah, that's the answer. Meanwhile, let me read one of the questions. So a person is asking, how does your journey start with application layer security, and how does one who's fairly new to application layer security start with the topic? Any recommendations helpful? So for me personally, I think I started with my background is basically networking, and I moved to security after a couple of years. So I think get your basics strong with networking first. You have to understand at least the OSI model, the basic networking concepts in the OSI model. What happens at layer 3, what happens at layer 4, what happens at layer 7. So application layer. It can be a rabbit hole if you keep getting into HTTP, and there's so many concepts around it. But I don't. So personally, I'm not read any one article or one book to understand application layer security. I'm sure there are a couple of books available on the market, but for me, it's just experience with working with multiple products and multiple areas of networking and security for many years. Yeah, so sorry to start with. I think there's probably also online courses that you can take on LinkedIn or Udemy. So I think that should be helpful. Um, all right, so I think the Q&A section is over. I also shared uh, the poll results. Let me see what's going on here. Oh, I think the sharing has been. I think someone is sharing. The host
Yeah,
is
I
sharing
shared.
the feedback.
Yeah, I shared the feedback. Yeah. So, any more thing to
Okay.
share, Giri?
No, I think I'm out of time, but I
Mhm,
wanted to
mhm.
show a demo of how Calico can be installed. But I think the
Okay, you can share.
uh,
You can take the control. Yeah, yeah, you can take the control.
uh, I'll just do it very quickly, just a couple of minutes. I'm not going to run through the entire thing, but since I already shared the documentation link, um, I think it's probably not super useful right now to go through the entire exercise. But maybe, I mean, I can just provide you pointers on how to start. So if you want to just install Calico and see how it works, you can actually do it even on your laptop. So if you just install Minikube, then use Kind, you can actually install product on your laptop and see how it works. But if through your work, if you have either Kubernetes like AWS or Azure account, you can go into these services and see how you can install Calico. And as I mentioned, there are a couple of ways you can install. Either install AKS with Calico for policy, and you can see that for policy you have Calico and CNI is not. And there's also an option where you can install Calico for both CNI and policy. So yeah, a couple of options there. And it's very super simple and straightforward. You just have a couple of commands here. One is start with creating a resource group on AKS, get credentials to access kubectl, install the operator. That's it. So this is an operator-based install. Uh, it's just one command here, and then configure Calico for installation. That's it, and you're good to go. So I wanted to do this, live in Kubernetes, but I don't think it matters anyway because it's just a matter of a couple of commands. And there's actually, I don't know if we have any workshops around application level policy, but I'm not sure if we do, but there is actually I think even part of the documentation, there's a demo where you can install a test application, like a banking application, and see how ALP works. So it's pretty cool. We've actually documented even the demo there. So that's all I had. I
Yeah,
really thank
thanks.
you all for
Yeah,
joining.
thanks, Giri, for a wonderful session.
Yeah.
Yeah, so I would request a round of virtual applause for this excellent technical session. And I think you give a lot of insightful information on the Kubernetes securities, where on the free version of your Calico. So it is extremely engaging, and I think our members have enjoyed the session on Saturday morning. Yeah, as I said, we used to do evening, but this was a change and good numbers, I think, around 185. So that's a
Yeah.
good number in the first time. We are doing probably first time. Yeah, I think this we can experiment. It shows that we can experiment this time in the upcoming CP as well. People accept that's the message which we are getting. The amount of information you have conveyed was immense, and I think it is relatively. That's why more than 25 questions posted by the participant. Last not the least, I want to thank you for all members who have attended this session and engaged in entire session for the last 1.5 more than near about 2 hours, and I know that some essential key takeaway for this and some homework for you. Thank you for all joining. As I said, keep watching our email for 11th March International Women's Day celebration. Physical, this will happen in person. Yeah, we have a limited seat, and those who are registering for that, you should attend. So that's very mandatory thing which we are saying, because post-COVID, the hotels are expensive. So we want the members who register only for limited members should come and attend this session. It's a full day event. And 28th of February is the last day of your renewal membership. Do it. Don't wait for the last day to do that. Yeah. So being said, and the CDPSC class, which is said, and the system class is there, please forward the membership. Do like our LinkedIn channel. We have amazing praise those who are liking more in LinkedIn and other channels. So that we will be announcing quarter to quarter in coming days. So that being said, thank you for a wonderful session, Giri, and have a
Sure.
good day.
Thank you.
Thank you. Bye.